Very good morning to all of you. Today I want to start session 9 of module 1, and module 1 title is subsurface exploration, and for this module 1 course outcome is given ability to plan and execute geotechnical site investigation program for different civil engineering projects. This is the course outcome. Subject title is Applied Geotechnical Engineering, and the subject code is 18CV62 in 6 semesters of civil engineering departments. After the discussion of all the theory concepts of subsurface exploration module, so we have discussed definition of subsurface explorations, program of explorations, objectives of explorations, methods of explorations, types of samplers, types of samples, methods of soundings, SPT test, DCP test, geophysical explorations, in that electrical resistivity methods, geophysical exploration methods, and drainage and dewatering concepts with different dewatering methods, and methods of lowering groundwater table by Horsley methods. So all the basic concepts of the subsurface explorations and drainage and dewatering theory. There are some numerical problems are asked to solve the methods of lowering water tables. So based on these backgrounds of the theory concepts, how numerical problems are asked, let us see. The water table, these problems I want to solve. That is example 1.5. The water table in a borehole was built to a depth of 11 meter below the ground level, and the recorded rise in water level in the borehole are as follows. H1 is 60 cm in 24 hours, H2 is 55 cm in 24 hours, and H3 is 50 cm in 24 hours. Estimate the groundwater tables. Okay, this is the problems. So here this problem is based on Horsley methods, how water table is located and determines. Solution: given data, depth is 11 meter is given, H1 is 60 cm is given, H2 is 55 cm is given, S3 is 50 cm is given. Time T1 is after 24 hours, how much it's required. Time T2 is 24 hours, and time T3 is 24 hours. How much water table is required? To find groundwater table equal to how much? Procedures. See here, so this diagram is based on Horsley methods. This is groundwater tables, this is tube wells, and this is depth of water tables, and this depth is H1, this depth is H2 with respect to groundwater tables, this depth is H3 with respect to groundwater tables, and small h1 is taken from the bottoms. After 24 hours, time is calculated here, T1 plus delta T, and here to here is H2, and it can be calculated based on the time. T1 plus 2 times delta T is nothing but a T after second days, and after third days time T1 is calculated T1 plus 3 times delta T with respect to S3 depth of water tables. That is, water is built from this diagram. Now we can use the equations by using Horsley methods. H1 is given by the empirical equation H1 square by H1 minus H2. Here substitute the value based on the given data. H1 is 0.6 meter, H1 is 0.6 minus H2 is 0.55. Answer is 7.2 meters. Use the equation for step 2. H2 equal to small h2 square by h1 minus h2. Now substitute the value here from the given data. H2 is 0.55, H1 is 0.6, H2 is 0.55. Answer is 6.05 meter. Calculate step 3, that is S3 equal to, equation is given H3 square by H2 minus H3. Substitute the value here from the given problem. H3 is 0.5, H2 is 0.55, H3 is 0.5. Answer is 5 meters. Next step 4, depth of water table, that is from H1 equal to 7.2 meter is calculated. 11 minus 7.2, answer is 3.8 meters. Depth of water tables from H2 equal to 6.05 meters. So here 11 minus 6.05 plus 0.6 plus 0.55. So answer is 3.8 meters with respect to this diagrams. Refer these diagrams. Okay. Next step, depth of water tables with respect to H3 equal to 5 meters. So from H3 5 meters. So now 11 minus 5 plus 0.6 plus 0.55 plus 0.5 means this 5 plus 0.6 plus 0.55 plus 0.55. So answer is 4.35 meters. Therefore, the average depth to the water table is given. So depth of water table equal to 3.8 plus 3.8 plus 4.35 divided by 3. Answer is 3.98 meter. So this is the depth of water tables from these diagrams. Okay. Next, problem number 1.6, that is sixth problem. It is desired to establish the location of groundwater table in a clay material. The borehole was built to a depth of 12 meter below the ground level, and the level of water in the borehole was observed to rise by 0.8 meter on next day, and 0.7 meter on second day, and 0.6 meter on third day. Estimate the groundwater tables. So this is also another problems. Based on these problems, follow the same steps. Solution. Given data, depth is 12 meters, H1 is 0.8 meters, H2 is 0.7 meter, S3 is 0.6 meter. Time T1 is 24 hours, that is first day. Time T2 is 48 hours, means that is second day. Time T3 is 72 hours, that is third day. So based on the problem, clear data is written here. To find groundwater table equal to how much? Procedure. Use the same steps of problem 1.5. Use the equation H1 equal to H1 square minus H1 minus H2. Substitute the value here. H1 is 0.8. Here H1 is 0.8 minus H2 is 0.7. Answer is 6.4 meters. H2 equal to H2 square by H1 minus H2. Substitute the value here. H2 is 0.7, H1 is 0.8, H2 is 0.7. Answer is 4.9 meters. And H3 is given by the equation H3 square by H2 minus H3. Substitute the value here from the given problem. H3 is 0.6, H2 is 0.7, H3 is 0.6. So answer is 3.6 meter. The next step, depth of water table is given by the equations. With respect to H1 is 6.4 meter. Total is 12, that is depth is 12 meter. 12 minus 6.4, that is 12 minus H1, so that is 5.6 meters. Next step, depth of water tables with respect to from H2 is 4.9 meters. So that is 12 minus 4.9 plus 0.8 plus 0.7. So answer is 5.6 meters. Depth of water tables, that is from H3 equal to 3.6 meters. So that is 12, that is total depth, 12 minus 3.6 plus 0.8 plus 0.8 plus 0.6. So answer is 6.3 meters. So then, therefore the average depth to the water table is given 5.6 plus 5.6 plus 6.3 divided by 3. So answer is 5.83 meters. So this is the average depth of groundwater tables. So this is the solutions for this type of problems. Let us see problem number 7. To establish the location of groundwater table in clay strata, water in the borehole is bailed out to a depth of 12 meter below ground surface. Rise in water was recorded at 24 hours intervals as first day 0.6 meter, second day 0.55 meter, third day 0.5 meter. Estimate the groundwater table. So I think this is also another problems. I think some data are changed slightly, but steps are same. Follow the steps. Here depth is 12 meter, H1 is 60 centimeter, H2 is 55 centimeter, S3 is 50 centimeters, and time T1 equal to 24 hours, time T2 is 24 hours, and time T3 is 24 hours. That is first day, second day, third day. To find estimate groundwater table equal to how much? Okay. Procedure. Given the standard equation based on the Horsley method, H1 equal to H1 square by H1 minus H2. Substitute the value here. H1 is 0.6, H2 is 0.6, H1 is 0.6 minus H2 is 0.5. Answer is 7.2 meter. While operating the calculators, we are getting the answer 7.2 meters. Next step, H2 is given by the empirical equation H2 square by H1 minus H2. Substitute the value here. H2 is 0.55 divided by H1 is 0.6 minus H2 is 0.55. Answer is 6.05 meter we are getting. Next step, H3 is given by the equation H3 square by H2 minus H3. Substitute the value here. H3 is 0.5 square divided by H2 is 0.55 minus H3 is 0.5. So answer is 5 meters. So now we have calculated capital H1, H2, H3 with respect to groundwater tables. Okay. Now to calculate depth of water tables from H1 is 7.2 meter. So total depth is 12 minus 7.2. Answer is 4.8 meters. Next step, depth of water tables, that is from H2 is 6.05 meters. So total depth of water table is water is 12 minus of 6.5 plus 0.6 plus 0.55. So answer is 4.8 meter. So based on the Horsley diagrams you see. Next step, depth of water tables from H3 is 5 meters. So then total depth is calculated 12 minus of 5 plus 0.6 plus 0.55 plus 0.5. Answer is 5.35 meters. Next step, therefore the average depth to the water table is calculated. Depth of water table equal to 4.8 plus 4.8 plus 5.35 divided by 3, because 3 times we have calculated depth of water table. So answer is 4.98 meter. So this is the solution of this type of problems. Next step, next problems. Estimate the position of the groundwater table from the following data obtained from the field. Depth up to which water is bailed out is 30 meters. Rise in the water levels on first day 2.2 meter, second day 1.8 meter and third day 1.5 meters. I will read out once again this problem. Estimate the position of the groundwater table from the following data obtained from the field. Depth up to which water is bailed out is 30 meters. Rise in the water levels on first day 2.2 meter, second day 1.8 meter and third day 1.5 meters. So this is the problems. Follow the same steps. Given data, depth is 30 meter, small h1 is 2.2 meter, small h2 is 1.8 meter, small h3 is 1.5 meters. Time t1 equal to 24 hours, that is first day. Time t2 equal to 48 hours, that is second day. And time t3 equal to 72 hours, that is third day. To find estimate groundwater table equal to how much? Procedure. So you follow the same concept here. Based on the Horsley methods, based on that diagrams, okay, the steps are given here. So here h1 with respect to depth of groundwater table is given by the empirical equation h1 equal to h1 square by h1 minus h2. Substitute the value here. h1 is 2.2 square divided by h1 is 2.2 minus h2 is 1.8. Answer is 12.1 meters. Next step, h2 is given by the equation h2 square by h1 minus h2. So now value is substituted here. h2 is 1.8 square divided by h1 is 2.2 minus h2 is 1.8. Answer is 8.1 meters while operating the calculators. Next step, h3 is given by the concept of the equation h3 square by small h2 minus small h3. Now substitute value in this equation. h3 is 1.5 square divided by h2 is 1.8 minus h3 is 1.5. So answer is 7.5 meters. Next, in step number 4, depth of water table is calculated from h1 is 12.1 meter. So then total depth is 30 minus 12.1. Answer is 17.9 meters. Depth of water table with respect to h2 is 8.1 meters. So then 30 minus 8.1 plus 2.2 plus 1.8. Answer is 17.9 meters. Depth of water tables from h3 is 7.5 meters. It can be calculated 30, that is total depth 30 minus 7.5 plus 2.2 plus 1.8 plus 1.5. Answer is 17 meters. The average depth to the water table is given 17.9 plus 17.9 plus 17 divided by 3. So answer is 17.6 meters. This is the average depth of water tables is calculated based on Horsley methods. So this is the clear solutions with respect to asked problems. See the next problems, that is example 1.9. Establish the location of groundwater in a clay strata. Water in box hole was bailed out to a depth of 10.6 meter below ground surface and a rise of water was recorded at 24 hours intervals. H1 is 64 centimeters, H2 is 57.9 centimeter, S3 is 51.8 centimeter. I think this is the similar of example 1.8 problems. Follow the same steps, that is solution steps, to find steps, procedure steps. Follow the same steps by Horsley methods. Okay, I think this is repeated. Next problem is the following size of sampling tube are available in the markets. The following sizes of sampling tubes are available in the markets. Outer diameter in mm 85, next sampler is 120, next sampler is 60 mm. Internal diameter is 82, next is 117, next is 45. Length in mm, 610 mm, 610 mm, third sample is 610 mm. Out of these ones, which ones would you select for obtaining undisturbed soil samples from a borehole? This is the problems based on samplers. Okay. So for this problem also you follow the same steps. Solution, given data. So data is given from the tables as usual, same table you write here, that is outer diameter in mm, internal diameter in mm, length in mm. To find which one would you select. Now follow the procedures. Here we know that area ratio is given by the equation AR equal to D square by D square minus DI square by DI square into 100. Now substitute the value in this area ratio equations. D is 85 square minus DI is 82 square divided by DI 82 square into 100. Now answer is 7.45 centimeter. By operating calculator we are getting the answer in percentage area ratio 7.45%. For second sampler, area ratio is given by the equation AR equal to D square minus DI square by DI square into 100. Substitute the value here. For second samplers, D is 120 square minus DI for second sampler 117 square divided by DI is 117 square. Multiply 100. Answer is 5.19%. For third sampler, area ratio AR equal to D square minus DI square by DI square into 100. Now substitute the value for third sampler dimensions. D external diameter is 60 square minus internal diameter is 45 square divided by internal diameter is 45 square into 100. Answer is 77.78%. So these are the calculations in terms of percentage for 3 samplers from the given problems. Now write the comments. Samplers with sizes outer diameter 120 mm, inner diameter 117 mm and outer diameter 85 mm, inner diameter 82 mm have area ratio is less than 10%. That is step number 1 and 2. Therefore, any one of them may be used. Normally, boreholes are diameter of 100 mm and hence a sampler with outer diameter 120 mm will require holes of larger diameter. Hence, from the point of view of economy, sampler with outer diameter 85 mm is preferred. So this is the solution for this type of problems. So these are the references or givens for session 9s. Thank you one and all. Next class I will be continue.